In this video, we're going to look at the case where you have a binomial that is the difference of squares, at the same time the difference of cubes. We won't go into real detail into just factoring. I've done some videos on general factoring. We know that the first step basically, especially if you have a binomial or a trinomial, is to take out a common factor, GCF. So here's your basic formulas. You have the difference of two squares. That factors into the difference of the square roots and the sum. Okay, so we can look at just a basic example here. So let's suppose you have, say, 4x squared minus 25y squared. So we look for a common factor. There's no common factor here, so we proceed to look at this and notice that it's a difference of two squares. 4x squared is a perfect square. 25y squared is a perfect square. So according to this first formula here, we should factor this into the difference of the square roots. The square root of 4x squared is 2x. Okay, the square root of 25y squared is 5y. So according to the formula then, this should factor into the difference of 2x minus 5y and 2x plus 5y. Okay, and that's the factorization for that one. Okay, pretty straightforward. Now keep in mind that normally when we have different squares, we say, okay, let's get a factor. If it's the sum of squares, we say it doesn't factor. Okay, technically you can factor pretty much anything. Generally you'll have to go through the imaginary numbers, but in the situation where you had basic algebra or whatever, generally the instructor is going to want you to factor these binomials or trinomials in terms of real numbers. So we say the difference of two squares or the sum of two squares, and it's not going to factor over the real numbers, factors over the imaginary numbers. Okay, the next one has to do with the difference of cubes. Now this formula tells you we have the difference of two cubes. The first factor right here is the difference of the cube roots. The cube root of x to the third is x. The cube root of y to the third is y. And then from the first factor you get the second factor. The formula tells you that the first term here is going to be the square of whatever the first one is. Okay, that's x squared. And then the signs change here, minus to plus here. And it's the product of those two roots, x times y, plus the square of the second root. There you have it. Okay. Now the formula for a sum of two cubes is pretty much the same. You can see the sign changes. If you have x cubed plus y to the third, then the first factor is the sum of the cube roots, x plus y, and the other factor is the square of the first root, okay, x squared minus the product of the two roots, xy, plus the square of the second root. Okay. So as a basic example here, we can look at, say, 8x cubed minus y to the third. Okay, 8x cubed is a cube because that's the same thing as 2x to the third. Okay, so the cube root of 8x to the third would be 2x. Okay, so according to this formula right here, the first factor should be the cube root of 8x to the third, which I said is 2x, minus the cube root of y, which would be y. And the second factor you get from the first is just the square of whatever this first term is. Okay, the square of 2x is 4x squared. And then the sign changes here, minus to plus. Then it's the product of those two, that's 2xy. Okay, and then plus the square of the second root. Okay, so that's how that formula works. And of course you can check these formulas by just multiplying what you have on the right side, and it should give you what you have on the left side. Now, when you're working factoring problems in a basic algebra course or basic algebra, sometimes your instructor will want you to factor the binomial or trinomial, whatever you're working with, completely. So you might have the instructions something like this: factor completely. Okay, so you can't give your answer if you don't take that the GCF and so forth. It has to be completely factored out. So factor completely. And let's suppose you're given this problem: x to the 6 minus y to the 6. Now, as a student majoring in math, I never encountered a situation like this. We never did really work with basic algebra in the courses I took. But this came up when I was actually doing my student teaching, and two students were working together on an assignment in class, and it was something like this. It turns out, let me just write it this way. See, x to the 6 can be written as x squared to the 3rd power, right? Because really this power to a power, you multiply the x, 2 times 3 gives me 6, so those are the same thing. I can also write this as x to the 6 is the same thing as x to the 3rd squared. Okay? 2 times 3 is 6. Okay? So what this means, of course, is that x to the 6, which also applies to y to the 6. I could do the same thing with y to the 6. X to the 6, because of this format right here, is a perfect cube. At the same time, x to the 6 is a perfect square because of this. Okay? So you can actually use the difference of squares or the difference of cubes to factor this, to solve this problem. So the situation occurred that one student was working this problem. Okay, so said factor completely, and this is what one student did. He said x to the 6 minus y to the 6. Okay, and he noticed this: x to the 6 was a perfect square, y to the 6 was a perfect square. So he said, okay, that's by the first formula up here. It's the difference in the sum of the square roots. So the square root of x to the 6 is x to the 3rd. The square root of y to the 6 is y to the 3rd, so it's a difference, x to the 3rd minus y to the 3rd, and the sum here, x to the 3rd plus y to the 3rd. But then again, it said factor completely, so then he noticed that, okay, well, here I have a difference of cubes, and here I have a sum of cubes. So basically then he used this formula right here, and he got this part of the problem. Okay, x cubed minus y to the 3rd power, or y cubed, x cubed minus y cubed, is first factor x minus y, and of course the second factor based on the formula is x squared plus xy plus y squared. And then for the sum of the cubes, okay, you got this formula right here. First factor is x plus y, and second factor is x squared minus xy plus y squared. And he said, is this right? And of course it is. And then he pointed out that his friend had gotten this. Okay, so his friend said x to the 6 is a perfect cube, because x to the 6 is, like I said a while ago, is the same thing as x squared cubed. So he said the difference in x to the 6 minus y to the 6 should factor into x squared minus y squared. Okay, which is correct. And then based on the formula for the difference of cubes, the second factor then will be the square of the first term. Okay, so x squared squared, x squared squared, multiply the powers, 2 times 2, we get x to the 4th. And then the sign here changes based on the formula, so it goes from minus to plus, and then it's just the product of these two, x squared, y squared, and then plus the square of the second root. And then he noticed that, yeah, now the first one here have difference of squares. So he said this should be x minus y. X plus y. And they just wrote this down and said, well, that doesn't factor. So this is plus x squared y squared here, plus y to the fourth. So you wanted to know who was right, okay? And of course, he was right because he went through the complete procedure, and he said, but why don't I get this answer? And I said, well, actually, this answer is not factored completely. It turns out, so you got x minus y is there, you got x plus y, you got x plus y there, and then we're missing this term, or this factor, and this factor. But it turns out that this right here factors into this factor and this factor. Except you have to use a little technique that is not only used in basic algebra, but you use this in a lot of advanced math courses, and that is adding 0 to an expression. Doesn't change it, right? If you add 0 to a number, it gives you back the same number, so you haven't changed it. If you multiply a number by 1, it doesn't change it. 1 times any number is the number itself. So what you have to think about here is this. If this x squared y squared was a 2x squared y squared, then this would be a perfect square. It would be kind of like x plus y. Let's look at this example. X plus y squared is equal to x squared plus 2xy plus y squared. Okay. And sorry for the writing, but I always have trouble with this little pen here that I use. Okay, so what we can do is, let's just make this a 2. Okay? So what I'm going to do is, I'm going to have x to the fourth. Okay, so I'm taking this right here, and then keep in mind, I'm working inside the parentheses here. Okay, so x to the fourth plus, and I'm going to add x squared y squared to this to make it 2x squared y squared, and then plus y to the fourth. Okay, but that's not legal because I've changed it. But if I put a minus x squared y squared, now it's the same thing, because 2x squared y squared minus x squared y squared gives me the same thing I started off with. Okay, so let's just look at this right here and factor it out. Then this, I hope you can recognize that it's the same thing as x squared plus y squared quantity squared. Okay, because this binomial x squared plus y squared squared is a square of this first one, which is x to the fourth, double this product, which is 2x squared y squared, plus the second term squared, which is this. Okay, so now if you look at this right here, or this next one here, now I have the difference of squares. Okay, here's the difference of squares. So one factor would be the difference of the square roots in the sum. Okay, so I can write this as x squared plus y squared. Okay, that's the square root, minus the square root of x squared y squared is xy. And then another one will be the sum of the square roots. So this will be x squared plus y squared plus x squared y squared. And this is all in parentheses. Okay. So this answer then, if you go ahead and complete it, is x minus y, x plus y, and then you take this right here and replace it by its factors, which is right here, x squared plus y squared minus xy, okay, which is this right here, okay, except we have the x squared and the y squared are not in the same order, but that's the same thing. And then over here we got x squared plus y squared plus x squared, and sorry, this should be square root of x squared y squared is xy. So this should be x squared plus y squared plus xy. Okay, so that's this one right here. X squared plus y squared and the xy. Xy is not out of order, but that's still the same thing. Okay. Okay, so the point that we're making here then is that if you're factoring binomials and you have one that turns out to be a difference of squares, at the same time also a difference of cubes, then do the difference of squares first and then take it from there. Okay, so like in this one right here, this x to the 6 minus y to the 6 is a difference of squares and difference of cubes. Okay, so first use the difference of squares method to get this answer, and then these right here turn out to be difference of cubes and sum of cubes. Then apply the formula for difference of cubes, and you don't have to go through this method here of completing the square. Okay, well, hope that makes sense to you, and thanks for watching. We'll see you in the next video.